Now we will discuss about cross-sectional elements of a typical non-urban road. Suppose this is the actual pavement, and actually this is not straight, some slight angle is provided, right? This is called camber. This slope is called camber. You will see in the next class. And there is some earth filled with soil, which are called shoulders. And now something like this. It goes down. Now we will see different elements and their nomenclature. From here to here, the actual width of the pavement is called carriageway. Width of carriageway, and these two, we have discussed, these two are shoulders, and here to here we call it formation width. And now this point is called road boundary. And we have two more lines, or imaginary lines, say. One is, this is road boundary, one is building line, and the other one is control line. Road boundary, building line and control line. And the distance between these two is called setback distance. We will discuss it later. Now what is building line? So if this highway is not enough, width of the highway is not enough, and they are going to increase the width, and then this boundary here and building line here, where whatever buildings are there here can be cleared up to the building line. If are not possible, they can clear up to control line also. So from here, this control line to this control line, whenever the highway is going to increase the width, it can be cleared. So control line is under the control of the government, we can say like that. Now formation width. What is camber? The slope, that is camber. That camber is different for different types of roads. Now I'll write high type bituminous road. High type bituminous roads or cement concrete roads. They are actually very strong, and the camber will be less. And then low type bituminous pavements, and then we have gravel roads or water-bound macadam roads, and we have earth roads. Earthen roads. And now we have two types of rainfalls, depending on the rainfall also. Let us say low rainfall, intensity of rainfall, low intensity of rainfall and high intensity of rainfall. If low intensity of rainfall is there, then you can say this is as 1 in 60, and here 1 in 50. Similarly, filling the entire tabular column, this is 1 in 50 and 1 in 40, 1 in 40 and 1 in 33. 1 in 33 to 1 in 25. These are different types of cambers. And remember, this camber is the minimum super elevation. Camber is the minimum super elevation. This and what are the widths of the carriageways? Formation widths we have to by heart. For example, I will say now carriageway width for a single lane is 3.75 meter. So this carriageway widths. For a two-lane road, it is 7 meter. Two-lane road with curve. If this is a two-lane road, suppose, and there is a curve here, we generally call it divider or something like that. Curve with curve, then two-lane road with curve. It is 7.5 meter. And now multi-lane highways, multi-lane roads. Suppose this is a multi-lane road. So 3 lanes here and 3 lanes on the other side. Then for a 3-lane road, what will happen? For a 3-lane, multiples of 3.5. So that is 10.5 meter here and 10.5 meter here. So this is all about. And formation width is 12 meter, 9 meter, 7.5 meter, 6 meter, whatever there. You have to by heart them and remember those things. This is briefly about cross-section elements of a typical highway. Now we will see about setback distance. So the name itself specifies that we are setting back by a distance. Suppose there is a horizontal curve and this line is the center of the road. Suppose first we are talking about a single lane road. Single lane road and this is the central line of the road. Suppose R is the radius of curve. Radius of horizontal curve. Of course we don't need the radius, data of the radius. Suppose this is the stopping side distance. And L is the length of curve. Suppose this length is more than stopping side distance. For instance, suppose LC is greater than stopping side distance, and now we need this radius R. Radius R. Suppose say total angle is alpha. Let us take half of this, that is alpha by 2. Now this becomes stopping side distance. Suppose S is the stopping side distance and this is S by 2. This arc, length of the arc is S by 2, and I will join this, and if any construction is there beyond this line, this vehicle, whatever vehicle is coming from this side, this vehicle can't see any object or vehicle on this side. So this distance should be cleared, which is called setback distance. We call this distance as setback distance. Now we need to find this. How to find? Let us say cos by 2 is adjacent side by hypotenuse. say some O and A. O and A, and this is hypotenuse R. Now you see this total distance is also R. So R is equal to this OA plus setback distance. Now setback distance is R minus OA, where OA is R cos alpha by 2. R cos alpha by 2. And this is for A. And what is alpha by 2? Length of the arc by radius in radians. That is S by 2 R in radians. You have to convert this in degrees, or you can convert directly and you can calculate. So this is R minus R cos alpha by 2. This is for a single lane road. What happens if the number of lanes is increased, or if length of curve is less than stopping side distance? Suppose say length of curve is less than stopping side distance. So length of curve is less than stopping side distance, then this alpha by 2 you can, this is also alpha by 2, and this distance will be added. This distance will be added, and that can be also derived but not needed. You can take it directly S minus LC by 2. This is here to here is stopping side distance, and you take this is length of curve and this is stopping side distance, S minus LC by 2 here, S minus LC by 2 here. Now you can directly add S minus LC by 2 sin alpha by 2. So for a single lane road, stopping side distance, setback distance is R minus R cos alpha by 2 plus S minus LC by 2 sin alpha by 2, where alpha by 2 is S by 2 R radians. Now what happens if the number of lanes is increases? Means suppose number of lanes, now it is 2. Number of lanes is 2, and this is the center line, and this is the center of inner lane. This one, I will take blue color. If this is center of the inner lane, of this horizontal radius, and this is the center of road, center line of road. Now this distance, suppose this is D, small d. Now this formula becomes, for as number of lanes increases, R minus D cos alpha by 2 plus S minus LC by 2 sin alpha by 2, where alpha by 2 becomes, now alpha by 2 becomes S by 2 R minus D, L by 2 R minus D. Remember this. This is all about setback distance.